Okay, good morning, everyone. Before I get started with my talk, at the break, I passed out the little white cards. So you have a little white card, and my hope is that as I'm giving my talk, if you have a question, you jot down that question on the card, and at the end, we'll pass them all to the wall, and I'll collect them. And I had two ideas for doing this. One is that I want to improve my training, my teaching of spray application, and there's a lot of different knowledge levels in this room, and so I'm very curious about what type of questions you have as I go along. It's a huge topic, and as all of these topics are, we could probably spend a short course on any one of these topics. So write down your question, and then I'll be able to look at those questions and have those for later. And also, I'm going to spend some time with you this afternoon with the sprayer, and so I'll have some time to look at those questions and maybe focus in on the topics that you're most interested in. If we have time and you have a question, I'm happy to answer it, but please also jot it down. Okay. So, yes, I'm going to be talking about the air-assisted sprayer and sprayer calibration today, so that means I'm not going to be talking about ground application or spraying herbicides. So spraying up, spraying the canopy itself, fungicides and insecticides. And, you know, it's nice to continue the mechanization talk with the workhorse of your farm, which is your sprayer. And also I consider this the first talk of our Integrated Pest Management, or IPM, session that we're going to continue tomorrow afternoon. Because, as my colleague and friend and co-trainer in spray application, Franz Niederholzer, says, the nozzle is the spearhead of IPM. And I love this quote because unfortunately we don't talk about spray application very much. We talk a lot about all the other aspects of IPM, but we really miss the sprayer. And it's sort of like you know, it's an analogy to hunting, even though I'm not a hunter, but I like the analogy. It's sort of like spending a lot of time, understanding how to identify your prey, how to monitor for your prey, knowing, thinking about when to go out and hunt it, and then sort of blindly throwing a spear, maybe the spear isn't even sharpened, and hoping that you're going to, be successful in your hunt. So it's a worthwhile topic. I hope you'll find. Okay, and the other thing about spray application has to do with this recent finding of some resistance to fungicides and powdery mildew. And so this is a powdery mildew on these grape clusters here, and we'll hear more about powdery mildew. This is the key disease pest that everybody, organic, conventional, you're all going to have to spray some kind of pesticide to control this disease in your vineyard. And unfortunately, some researchers are picking up some resistance to fungicides, and that is causing some people to say, is it resistance or is it something else? So did I do a good job of getting good coverage or not? So anyhow, so what is calibration? Now, calibration is, this is the definition, it's the act of selecting, establishing, maintaining, and verifying sprayer operation parameters which result in a known, desired, and uniform application rate of spray material. And I like this definition because it's active. We have choices, so we're going to select these operation parameters. We're going to try to establish them to the best of our ability, maintain and check whether we've actually maintained and established those parameters to give us this known, desired, and uniform application. So there's a lot of calibration formulas out there, and it's kind of a stumbling block, I think, to people. But this is the basic spray formula that I always go back to. It's a fundamental relationship, and it's fairly simple, and it says that your spray volume per acre, or your gallons per acre, is equal to the flow rate over the land rate. So the flow rate in gallons per minute over the land rate in acres per minute. And it's a relationship. So it tells you something about how the spray volume per acre is going to change if you change one of those parameters without changing anything else. So it's a direct relationship with flow rate. So if we increase flow rate, we're going to increase our spray volume per acre. And it's an indirect relationship with land rate. So if we increase our land rate, or one of the components of land rate, speed or swath width, we're going to decrease our GPA, and vice versa. So it's a great relationship. It works for any sprayer, so it would work for a ground application sprayer, as well as a backpack sprayer. And you don't have to remember any conversion factors. You know, we can look all those up on our phones if we forget them, so you don't have to stumble over how many feet per mile and all these things that we can stumble over. So I'm going to go through this calibration formula because correct calibration is really the most important step in optimizing coverage, and that's our goal. Flow rate over land rate. So what is land rate? Well, most people, when I ask that question, they'll say speed. But is it just speed? And the answer is no. It's an area covered in time. Okay, so rates are in time. And land rate is the speed times the swath width that the nozzles cover. The flow rate that you're measuring is related to this swath width. So it's speed times the swath width that sprayer is covering. And because we want to come up with units of gallons per acre, we can measure our speed in feet per minute, or we can convert it to feet per minute. Typically, we measure it in feet per second. And then we have our swath width in feet. We can multiply that and get our square feet or area, and then convert that to how much of an acre that is that the sprayer covers per minute. And that's our land rate. So the swath width for vines is typically the row spacing. So it's set. It's set when you plant your vineyard, right? So that is your swath width. So in a typical application, we are going to try to cover half of each side of the row. And it can be easily measured with tape. You should check it. Most growers know what that swath width is. Now, to measure speed, there are a few things that you should do. You should measure your speed in the place, in your vineyard, ideally, because of tire slippage is going to change on soil as compared to gravel or pavement. So the terrain should be typical for the spray job. If you farm on slopes, like most of my growers do, you should measure your speed on slopes. And you should never use the tractor speedometer you should always check that your speedometer is accurate, right? Okay. So, and noting the gear, the tractor gear and the RPMs, typically so that will be typically 2200 or whatever it's set to give you a 540 PTO RPM. Take multiple runs and then take an average. Okay, but how fast do we go? So this is really where we start thinking about calibration and what gives us adequate coverage, because we'd like to go as fast as we possibly can to save time and money, but maintaining that good coverage, right? So how do we determine how fast to go? So often this is where we start with determining our calibration for our vineyard, is to determine our speed. And there's a few tools you can use to help you look at that. And it's really a relationship between the fan and the ground speed and the canopy that determines how fast you can go. Because one of the jobs of the fan, and that's, this is what allows us to spray these vineyards, is this fan. This is what makes air-assisted spraying unique. one of the jobs of the fan is to open that canopy up, to perturb it so that that spray can enter into the canopy. And so you have to go slow enough, depending on your canopy, to allow the fan to do its job. And that changes during the season. So vines are very different than trees. Vines are growing the entire season. You'll see a canopy change, right? Whereas trees, they pretty much go through their bloom, and then they leaf out, and the canopy is the same for the entire season. We have canopy growing the entire season in vines. So there's a lot of changes going on. So the tools you can use, and here's a sprayer like we'll look at this afternoon. This is the back of the sprayer. The nozzles are right here on this trellis housing. So we can attach some flagging or some ribbon to the edge here, and we can also attach it to the outer sides of the row. Can't quite see it in this picture, that we're spraying. And we can look at how that ribbon flutters as we're driving past it. And I didn't quite get the photo showing the ribbon fluttering here, but you can see we tied ribbons, and this is at Oakville actually last June. It'll look a little different today, but we had a spray day session there, and we tied ribbons all over. You can tie them all over the place, so you can see that the ribbons here help you dial in your air to match your canopy, so it's right there, so that's helpful. And then this, you would be looking at the fluttering of these outside ribbons to see if your air was adjusted properly. And what you'd be looking at is how much that ribbon is fluttering. So something like this little diagram, that's from Sprayers 101, which is one of my favorite websites, with Jason DeVoe and Tom Wolfe doing an excellent job. So I recommend visiting that site. And what you'd be looking for is you'd want that ribbon to be fluttering just about in here at 25 to 45 degrees. If it was fluttering, if it was sticking straight out, it would be telling you that there's too much air, so that air is pushing through the canopy, and that therefore your spray would be pushing through the canopy and basically missing the canopy. And if your ribbon wasn't fluttering at all, it would be telling you that the air is basically too slow. So you'd need more air. And you could make some adjustments to that, which we'll talk about in a little later. So that's the bottom half of our equation, really, is we've got our speed times our width. And we convert the units to acres per minute. And now we're going to look at flow rate, gallons per minute. So the nozzles are, of course, what control the flow rate, the nozzles in relation to the pressure that's used. And this is a disc and core nozzle. This is the back side of a disc and core nozzle. This is a typical nozzle used in many air blast applications. And the nipple is facing up, so when you put this combo on your sprayer, you want that nipple to be facing the sprayer. And so this is what that looks like when it's blown apart. So here's your disc, and here's your core or spinner plate. So these are two nozzle parts that combine to give you one flow rate, right? And here's your filter. These are extremely important components. There's several filtration places on the sprayer that are critical to keep clean. And this is basically the manifold for the nozzle to hold it all together. And you can see that this one is sometimes growers call these a 4-hole or a 2-hole. This is a 4-hole spinner plate. It's called a spinner plate, but it doesn't actually spin. It stays stationary, and as the liquid is passing through the disc and into the core, it speeds up and goes through there. And these come in different sizes. And you'll see here in a minute. And this is what it looks like when it's on the sprayer. And this is a check valve right here next to that disc and core nozzle that is preventing flow into the nozzle. So that helps prevent dripping when the nozzles are turned off. Okay, and you can also have nozzles that are single-piece nozzles. Okay, so this is a setup that we did for a citrus demonstration. So you look at how many nozzles there are on this machine. There's really high flow rates for citrus, and these are relatively new to air blast spraying. They've been used in Europe for a long time, and now we're starting to see them used more here in California. They're single piece, and they're kind of nice because they are color coded. And so on those disc and core nozzles, I'll back up. The size of the nozzle is printed on here. This will say D2 to D4 to D6. And it's also printed on the very edge of this. It's extremely difficult to see. So that size of the nozzle correlates to the flow rate. So if you forget what nozzles you have in there, or you tell somebody to go set up your sprayer with a certain disc and core nozzle combination and they can't see what's stamped on those brass fittings, you may not get the nozzles that you think set up in your sprayer. So you have to be careful about that. And I always recommend that people keep a spray application notebook for each block that you have, because you probably have different row widths in your block, and for the nozzle setup that you use at different times of the season. That's why don't they just color the disc and cores? Well, that's what they've done here with the single piece, right? So you see these blue nozzles. Here's a black one. So that helps a lot with recalling what kind of nozzle setup you have. Okay, so what does the nozzle contribute to our spray application? Well, flow rate. I've already talked about flow rate, and it's directly proportional, right? So if we increase our flow rate, we'll increase our volume per acre, our spray volume per acre, if nothing else changes in our application. And how can we do that? We can either do that by increasing the nozzle size, so choosing a larger nozzle, except for, and that will cause larger droplets, except for Venturi sprayers, which only produce fine droplets, and I'll show you one of those in a moment. Or you could increase the pressure to get a higher flow rate. And that's not typically what we recommend, because the pressure to flow rate relationship is not a direct relation. Is a direct relationship, but is not a one-to-one relationship. So in order to double the flow rate, you'd have to square the pressure. So you'd have to increase the pressure 4 times to double the flow rate. So, and that would cause smaller droplets, and smaller droplets drift more easily. And we'll talk a little bit about that also. So, so when you start out, how do you know what the flow rate is of your nozzle selection? Well, this is the first thing you should do is you should go to the manufacturer's catalog for those nozzles. And if you don't have that catalog, you should get it. They're all online. They're all available online as PDFs. They're available in Spanish. So whoever's setting up your sprayer should have this information about the nozzles. And here you can see the 2 different types of nozzles that we have. I feel like I'm neglecting you guys over here. So the Ds and the DCs, the disc and the core nozzles. And up here you see the range of pressures that those nozzles are operating at, and what the manufacturer says at that pressure that nozzle combination should deliver in gallons per minute. So for example, a D4 DC23 at, I think that's 100 PSI, which is typical, that's going to deliver something like 0.23 gallons per minute. Okay, so that's a place for you to start with what your nozzle combination should be delivering. The pressure gauge is an incredibly important component that often gets overlooked. You wouldn't believe how many times I visit someone to help them with their sprayer and their pressure gauge isn't working properly. So it'll either be clouded over, it won't be maintained with fluid, So make sure it's working properly, because you're going to note the pressure that you operate at, so that you can know what your flow rate is. It's related to the pressure. And make sure that the pressure gauge is of a scale that's typical for what you're going to be spraying at. In other words, you wouldn't want to pick up a gauge that is 0 to 1,000 psi, because you wouldn't be able to see those very fine pressure readings. So here's those cone jet nozzles, and you can see, instead of having the two pieces, the disc and core combination, this is one row, so it's one piece nozzle, and they come in all these different colors, cool colors, and then you can go over and you can find what the flow rate would be for that nozzle. And there's a pretty good range for Vineyard applications. There's a pretty good range, so you can pretty much, if you have a disc core combination that you like and you want to try a single piece nozzle, you can probably find a very similar flow rate for those nozzles, because typically we're not spraying our vineyards at real high flow rates. If you're in a tree situation, you would probably have to nozzle up more of those cone jets to get a similar flow rate as your disc and core. Okay, so you've looked at the catalog, you know what that nozzle should deliver, but now you should always check to what it's actually delivering. And the reasons for this is because most likely your pressure isn't going to be spot on. You know, I mean, you might shoot for 100 or 150, but you might end up at 125, so it could be different. And most likely you're not going to be working with brand new nozzles. Right, so they're going to be worn or start to wear. So how do you do that? How do you check your flow rate, or see what it actually is? And there's a few ways to do it. The old school way, which works great, is to park your sprayer on a level surface, to fill it up to a verifiable spot, like on the rim of the fill, right there. To close it up, bring your throttle up to the RPMs that you would operate that at for the PTO, and then open all of the nozzles and spray it out, noting the pressure and the time, right? So you're going to spray it out for 20 seconds, 30 seconds, 45 seconds. And really how long you spray it out for depends on the method with which you're going to refill it. Right? So, because if you're going to use a bucket, you can use a bucket to refill it, then you're probably not going to want to refill 35 gallons back into the sprayer. Right? So you might want to shorten the time, but the longer that you do leave it open, the more accurate it will be. So, and then you always want to calibrate these buckets, of course. So then here's Franz refilling it, and so you're going to note the volume, so then you'll know how many gallons that sprayer sprayed out over that set amount of time. If you don't want to do this labor, you can get a flow meter and hook it onto a hose and use that to refill your sprayer, and that works pretty well. Or you can use a fancy gadget like a Spot On, which gives you the gallons per minute. I've got these. I can show you what this looks like today. But this requires having some way to individually measure the nozzles, right? And that's what makes calibration so much more difficult with an air blast sprayer than with a herbicide or ground sprayer, right? Because you've got that fan, you've got all those nozzles going, so you need some way to capture that flow from each individual nozzle, which means you need some kind of a nozzle adapter to hook on there. And I'll show you a homemade version of one that you can make yourself, and I'll show you this fancy one that you can buy this afternoon. So you hook up those hoses, and then you would measure the individual flow rate. So that's really useful information, because it tells you if any one of those nozzles needs to be replaced, right? So that's individual nozzle information that you wouldn't get with the entire sprayer. Okay, so what about one of these sprayers? Okay, so this is a different type of sprayer that's fairly common in vineyards. It's called a pneumatic sprayer, or sometimes a low volume Venturi sprayer. So where is the nozzle on this machine, right? So you might think it's here, because this is called a fan Italian finger setup or fan and finger setup. Or you might think the nozzles are down here, but actually the nozzle, if you take it apart, here's this yellow disc. So the flow is coming from the tank and going through this yellow disc. And so the yellow disc is the nozzle, actually. It's what's metering the flow out of that type of sprayer. And on these yellow discs, it's here. So the hole is right there, right? So the hole's right there. That's where the nozzle is. That's where the orifice is. And the size of the hole is correlated to how it's called a dial-a-rate. So they've got these different holes here around the yellow disc. You choose one that's opposite of where your actual outlet is based on the chart. So again, there's a chart related, and it's all related to pressure. And it's got the disc settings there, so you can see what the flow rate would be for a specific setting on a Venturi sprayer. And this is if you look up these charts, if you have a Venturi, like a Gearmore or Cima sprayer, if you look this up, make sure you get the chart that correlates to the sprayer you have. So there's a two yellow dial-a-rate disc, there's a 4, there's I think a 6 and an 8. So you'd make sure you've got the right chart for that. And in some ways, this is actually much easier, because you can actually here. I was helping a grower calibrate this sprayer, so you can actually undo this and measure directly, almost like a ground sprayer, right? So you can measure the flow rate from one of these pretty easily. And we compared that to filling it up, spraying it out over time, and refilling it, and it was almost spot on. And actually, one thing we learned when we did this was that those little discs, they can get kind of moved a little bit. So if they're not straight on, then that's going to affect the flow rate. And when we did this on the one side, the grower, who's right there, he said, "Oh, that's why that side of the sprayer always looked a little weird when I was spraying it, because the disc wasn't quite on." So you do have to kind of jiggle it or finagle it to make sure it's straight on. And we'll talk a little bit more about those types of sprayers a little bit later. We'll talk about fans, droplet sizes. Okay. Okay, so we've got our flow rate now, and we've got our land rate. So we should have arrived at our desired gallons per acre, right? So you would take the flow rate of all of those nozzles and combine them, or all of those nozzles that cover that swath width, right? So flow rate, land rate, those are the variables you need to check no matter what formula you use. Maybe you've already been calibrating and you like a formula. That's fine. That's great. This is the most common formula that I see out there. It's one for measuring gallons per minute. And it's, as you can see, it's the GPA times miles per hour, because often people have their speed in miles per hour times swath width, and over 495, right? So what is that? That's a conversion factor that's just a conversion factor for the same formula for the speed to the acres, right? It's the same formula. It's just a change on what variable you're solving for. So it's the same formula. And then, just to be clear, because I'm not sure about the knowledge level in the room, just to be clear, what we've done so far is we've calculated the volume that the pesticide that we're going to be using is going to be dispersed in, right? So we haven't yet determined how much pesticide we're going to put in our tank. We've determined how much volume that pesticide needs to be in to give good coverage without drift. That would be the goal. or runoff. So I say the first and final step because typically when we're spraying it, we start with the label. It's the legal document, right? And the label will specify the amount of pesticide or the rate per acre. So this is the pesticide rate per acre. And here's an example of a label for Applaud, which is an insect growth regulator used for mealybug control. And there'll be a range of rate here. And so, the recommendation here is no more than 24 ounces per growing season to control mealybugs. And we're starting to see labels actually talk about some of the other parameters of spray application. For sure, we're seeing that with herbicides. We're seeing that labels talking about droplet size on herbicides, but I think it's probably coming for insecticides and fungicides as well. So, but what this label states is, and often this is kind of the catch-all, sufficient coverage or good coverage is essential, right? And use higher volumes under adverse conditions or with dense canopies, okay? So they want you to get good coverage here. So going back to that how much pesticide in the tank, to calculate that, you have to know how many gallons your tank holds. And so, that's a manufacturer's spec. That's what most growers use. The recommendation among the spray geeks is to actually measure how many gallons your tank actually holds, because it's going to vary. It's not going to be exactly 50 gallons or exactly 200 gallons. And so if you're buying a sprayer, a brand new sprayer, it's a nice time to do that. You only have to do it once if you do it. So, but that does mean metering in flow and measuring how much your tank actually holds. And then if you do that, you can create a dipstick, and you can put notches on it for, whatever makes sense for your sprayer. So if it's a 50-gallon tank, you might want a notch every 10 gallons. If it's a 200-gallon tank, you might want a notch every 25 gallons. And then you can use that dipstick, and you can use it to, when you're filling it, and you can also use it to make sure that the sight gauge, which is that outside piece of hose that shows you these spots of how much volume is in your tank, to see if that's correct. So in our example here, we're saying it's a 400-gallon tank. We decide 12 ounces per acre based on the label. And we calibrated our sprayer to say deliver 118 gallons per acre. Then we know that our 400-gallon tank at 118 gallons per acre for this application can do 3.4 acres. And the amount of pesticides we need then is that amount of acres that we can do per tank times the rate per acre, right? So we'd put 41 ounces of Applaud in the tank, and off we'd go. So how do you know so you go through all this work, and calibration is a lot of work, actually. If you've never calibrated your sprayer, plan on spending a day to calibrate it. Maybe it'll take you less time, that'd be great, but it takes several hours because it's a process, right? We're selecting, establishing, maintaining, verifying, and maybe the verification is like, this is too much drift, or I'm not getting good enough coverage. So I need to go back and change something. So how do you know if you've dialed it in right? Well, checking for coverage. Okay, and this is a cluster with mildew. You can see mildew here that's been sprayed with oil, horticultural oil. And this is kind of typical for a lot of spray applications. You'll see that we miss the back side of the cluster, right? It's a hard place to actually get good coverage on, and I'll tell you why in a few moments. So you can use water-sensitive paper. This is a great tool to give you a presence or absence on whether you're actually hitting the target. And I like to put the water-sensitive paper right where the target is that I'm trying to kill. And in this case, it's this mealybug right here. This is the Gills mealybug, which is present in the foothills, not present in a lot of other regions in California. Lake County has it, maybe Mendocino. And so here's where I stapled my water-sensitive paper. So this is paper that turns blue. So it's yellow when it's clean, brand new. And then as soon as water or oil hits it, you get the blue spots. Okay, it's kind of hard to handle. So one of the ways I like to use water-sensitive paper is to staple it to a tag, like this is a postal tag that you can get at the office supply store, and then you can write you can take notes on, you can say this is where I put the water-sensitive paper. This was the sprayer settings for this, and you can look at the coverage and go, wow, I liked that setting, and you can put that tag in your spray notebook and go back and go, yeah, that's what I got with those settings at that block at that stage of growth, and I like that. You can also use kaolin clay, or this is commercially sold as Surround. When people use kaolin clay, they get a really good idea of what their sprayer's doing. If they're using it for the first time for sunburn or for some other reason, for mealybug control or some other reason, wow, I really got an idea of like how much spray was hitting the ground. You can see it all over the drip tubing here. Or you can do a visual check for coverage, and this is I've worked in apples as well as grapes for a while, so this is an apple trial I did. And you can you can actually walk behind the sprayer in PPE, right? You want to have your safety equipment on, and you can actually look at the fruit and see it. Am I hitting it? So, I'd like to talk a little bit about droplet size. Okay, so the other thing that the nozzle contributes to our spray application. So it's not just about flow rate. So droplet size, and why is droplet size important? Because it's coverage and it's drift, right? So I think of coverage as the opposite of drift. And the thing about nozzles, hydraulic nozzles that you have to know, so those would be the ones, anything but an air shear, anything but a Venturi nozzle is a hydraulic nozzle. So these hydraulic nozzles, they produce a range of droplet sizes, right? And the engineers that are creating these nozzles in the lab, and this is a photo from the TJET catalog, they use lasers to measure the droplet size ranges for these nozzles, okay? And droplet size is measured in microns. And a micron is 1/39th of an inch. 1/39 millionths of an inch. 39 millionths of an inch. And I don't think that we stress how tiny droplets are. Okay, so, and it gets into the physics of droplet movement. So all droplets, even what we consider relatively large droplets, are pretty small, really, when we're talking about microns. For example, in this diagram here, this is showing you a human hair. This is how large a human hair would be relative to a micron here at 39 millionths of an inch. And so we generally talk about the range of droplet sizes. We use microns as the unit for the size of the droplets. But the range of droplet sizes are typically talked about as volume median diameter, or VMD. Right? And the typical VMD that you will see for any one nozzle is the VMD 0.5 or 50%. And what that's telling you is that for that nozzle, half of those droplets are larger and half of them are smaller. So the VMD, if you have a relatively large VMD, you still have a lot of fine droplets coming out of that nozzle. And then there's other measurements which you probably wouldn't find in a catalog. So, because all of this is, kind of a lot, right? So now we're talking about droplet sizes. The association, the American Society of Ag and Biological Engineers, came up with a universal color coding for droplet sizes for nozzles. So we've got this color-coded droplet size. So on this chart, we've got the category of the size of the nozzle, or of the droplets. And so these would be going from ultra coarse to extra fine. And then we've got, and that corresponding to a VMD, a volume median diameter range, of greater than 650 to less than 60. Okay? And then we've got the corresponding color coding here. And it kind of goes from, you know, red, purple, red, unfriendly, eco-unfriendly sizes. So more driftable droplets, those very fine droplets, to, you know, yellow, blue, more green, eco-friendly droplet size, and even then white and black for the ultra coarse. So this is a single piece nozzle. It's with that produces larger droplets, and it's a air induction nozzle, and it's got an air hole right there, sitting in there, that we sometimes also call these Venturi nozzles. And these are nozzles that have been used for a long time in herbicide applications. So the herbicide guys, they've had to be really concerned about spray drift for a while, you know, a long time. And anyone who's heard the dicamba story that's been on NPR recently knows that. Okay, so these there's a range of drift reducing nozzles. And some of those are now available for our air blast applications. So we have these AI nozzles. And I'll show you what those look like this afternoon up close. T-Jet isn't the only producer of I'm in no way trying to advocate T-Jet. It's just a very popular nozzle company. There's also many other companies. Albuz makes these nozzles. It's very popular in Europe, and you can get them here in California. Greenleaf, Leckler, this is a Leckler nozzle, AI nozzle. So you can get these nozzles, all different types of nozzles from all different types of companies. And so here's where the color coding gets a little tricky, because the color coding for droplet size is in the middle of the chart here. It has nothing to do with the color of the actual nozzle. Okay? So just because you have a green nozzle doesn't mean you have a large droplet size producing nozzle. And I don't know why they did that, but that's, you know. So when we're talking about spray quality or droplet size from any of these nozzles, we're looking at the center color in the chart there to see what the spray quality is, or the droplet size, average VMD. And so why do we care about droplet size anyhow? Well, I've been talking a little bit about drift, sort of. And coverage, so coverage is the opposite of drift, and coverage is what we're really aiming for. But how driftable are droplets? And this brings into play another component of spray application, which is weather, right? I'm not really going to have a lot of time to talk about weather, but weather influences how droplets move, and it influences based on the size of the droplet. So here you have this chart where you have these very fine fog to extremely coarse droplets. And this column here tells you the time it's required to fall 10 feet. Okay? So you see that these fine droplets stay airborne much longer than these larger droplets, right? Because of the force of gravity. They're larger, they're going to drop out of the air quicker. So those finer droplets remain airborne longer, and the longer that they're airborne, the greater the time that something can go wrong between the time that they leave the nozzle and reach your desired target. Right? So the longer they're airborne, the more time they have to miss the target or go off target. And this is greatly influenced by environmental conditions. I mean, not only wind, but also temperature, humidity, inversion layers can all affect droplet movement, and affect more so on finer droplets. So in this chart, we see that these very fine droplets can move as far as 1,100 feet in a 3-mile-per-hour wind. A 3-mile-per-hour wind is actually what we would consider pretty good spraying conditions. We like 3-mile-per-hour winds. And look at how far those droplets move. They move far, and they move far fast. So, so that's what I wanted to show there. Also, the deposition efficiency of droplets is a combination of not only the droplet size, but also the target size and the velocity, the terminal velocity of the droplet. And so this is you could imagine this being a grape berry or something. And as air is flowing through past this, the tendency is to go around the target in these air streams. And those finer droplets are entrained in this airstream, right? So those finer droplets will tend to move around the target, right? That's why it's so hard to hit the backside of the cluster, because that air is moving fast. So you could slow down the air, that helps, or you can use a larger droplet, and then that larger droplet is less likely to become entrained in that airstream that's basically missing the target. Okay, so I'm going to talk just a little bit about some fundamental things about selecting an air-assisted sprayer for your vineyard. And this is a basic diagram of the components of an air sprayer. But they're all there, even though it's a pretty basic diagram, right? So we've got the tank. We've got agitation requirement in the tank. So the agitation is either a mechanical agitation, so a paddle, or hydraulic agitation. So hydraulic agitation means there's another nozzle in the tank that's providing that agitation. Agitation is critically important. It's critically important for all these, like for sulfur falling out and oil. I mean, you don't have to just be using the hard pesticides for agitation and spray application not to be important. It's important for all of these things. So agitation, critically important part. The strainers, you see the strainer on the top of the tank. Here's the pressure gauge, essential component there. The pump, I'll talk very briefly about pumps. And this pump has this setup has a pressure regulator. Surge tank, that's for the pump, actually. Control valves here, the fan. So the fan is really the key here for selecting a sprayer. And, of course, the nozzles. And here's what it really looks like. And we'll look at this up close and personal today. But I really recommend that everybody uses a sprayer, knows, can point out the flow, how the flow moves through the sprayer. How does it get from the tank to the nozzle? Okay, so in this case, we're looking at the underbelly of this rears that's got a diaphragm pump that's coming from the flow going through here. Here's the filter. Here's a strainer. It's going first through that suction strainer, which is critically important to keep clean. Should clean that actually after at the end of the day. And then it's going to this diaphragm pump here, being pumped out and then up to the pressure regulator. And actually, you can't see it, but it's because it's cut off in the diagram. But then it would exit, go to the nozzles through here. And the other thing to point out here is here's the fan gearbox. So this is a gearbox that can control the speed of the fan. Some sprayers have these, some sprayers don't. So you can slow down the fan if you have one of these fan gearboxes, which you might want to do. So in selecting a sprayer, all of the components that affect your vineyard site capacity, how big your canopy can get, really should have some effect on the sprayer selection that you make. Because ideally you want to match your sprayer to your canopy, to your maximum canopy, right? Canopy at its largest in a good rain year. So everything, so vine age, variety, rootstock health, all matter. And some adjustments can be made to some canopies, right? I mean, some sprayers. Some adjustments can be made to canopies too, right? We just talked about it, leafing, shoot pulling, and that can help a lot too, for sure. So generally, generally, we see 3 types of sprayers. They each have a fit, right? Every spray job is unique. That's another challenge we have in spray application. All these changes that we've talked about match the machine to the job. So here's a Axial fan air blast sprayer. This is the type that we'll be looking at this afternoon. It works under higher pressure. It can take the disc or core or the single piece nozzles, and it's got an axial fan, a high volume fan. And it's got these options for directing airflow. So you can put a tower, a mini tower, they call this a trellis. Rears calls this a trellis tower for grapes. If you have a bigger canopy, you can even get these bigger towers here. Or you can use it without the trellis. Then you've got the Venturi, which we've already talked about. The Venturi works with a different type of fan. And this is a key difference. Other than the 2 differences between the 2 sprayers are the Venturi has the air shear nozzle, only fine droplets, fewer choices on flow rate, really. Really no choice to get a larger droplet with a Venturi machine. But the other thing about a Venturi is that it uses a centrifugal fan. So it's a low volume, high speed fan because that's how it's creating droplets. It's an air shear. So it has a lot of speed but a low volume. They work at low pressures. And there's options, right? You can get the over-the-row type. And then we have, making the best use of our mechanical harvester investment option, right? So, so we have these multifunction self-propelled sprayers, which are basically fitted with attachments to increase their utility, right? You want to use it, make this investment, you want to use it more often. The question is that the best fit for your canopy? So these, they can have either type of nozzle. And they pretty much work with the centrifugal fans. So the low volume, high speed fans. And you can get them over the row as well. So I want to just talk a little bit about what the job of the fan is. Yeah, I think Mark's on top of it. Thank you, Carrie. But oh, good. That's excellent. I'm glad. We're almost done, and this is really an important point. So bear with me here. I don't want to keep you any longer here, but my previous speaker went over, so give me my time. So let's talk about the fan. I always like to say, is it our friend or is it our foe? Because it can be both, right? We need the fan. It's got essential functions. So the essential functions of the fan are to transport the droplets to our target, to entrain them into the air to reach the target, to perturb the canopy. So again, you have to base your speed on giving that fan enough time to work. If you have a bigger canopy, you're going to need to go slower to perturb the canopy enough to get penetration. Improved deposition, is to put the air in motion with the droplets so that they don't have to fight the force of drag as much. And also to atomize those droplets. But it can also be a foe, right? So this is where a lot of money goes in to the power. So the fan that you choose, you have to be able to power it. So you're going to need the horsepower. It's going to take larger horsepower for a larger fan if you need a larger fan. You may not. Velocity needs to be high at the exit point. And by the way, this is often a selling point, right? The manufacturers try to make a big deal about high velocity coming out of the fan. That is not the main thing that we want to look at. We want to actually look at air volume, not air velocity. Okay, so that it's very fast coming out of the outlets, but it drops off quite quickly as you move away. It's the air is diluted by the ambient air, and that's what we're fighting. So do those droplets actually reach the target, or do they blow past the target? So two types of fans, I've already mentioned this, axial and centrifugal. I don't need to say anything more about that. And here's a range of fan sizes here from 22 to 36 inch. And here's the recommended horsepower that you would need. So the most important consideration is to match the fan to the crop canopy. This is a technical formula on estimating how much air volume you would need depending on your ground speed, depending on the canopy dimensions, and then also including a factor for density. Okay, so so this and this is a chart that's from CCW Cooperative, which I understand is one of the largest grape growing cooperatives in Australia. And they have this online pamphlet that I found useful on vineyard spraying principles. And this is just an example here of different sprayers with different fan types. And so because it's all in metric, I picked out a couple and converted them to English units for us who can't make the conversion very quickly. So, and what's this showing is it's showing two different sizes canopies here. This is a 2.5 by 3.25 foot canopy, and this is a larger canopy, a 5 by 5 foot canopy. And what they're estimating is how fast you could drive, depending on how large the fan that you have is. And here's the theoretical air volume output of these fans. So a turbine, this is a centrifugal fan, a 22-inch centrifugal fan might give you 6,000 cubic feet per minute, whereas an axial fan, that's a 35-inch, pretty big fan, would give you something like 50,000 cubic feet. So it's a lot more volume, right? So all of this is just to emphasize that the air needs to be considered in the context of the sprayer, the canopy, and the tractor speed. Are we good? Okay. Okay. And so slower air. So slower air can be desirable. Okay. We already talked about slowing down the air to hit the back of the cluster, the back of the leaf, if you're trying to control mites or mealybug crawlers. So slower air can be desirable. And so what can we do to control the air speed? Slow it down. We can adjust the fan gearbox. We can lower the tractor RPMs in some situations. We can do a technique called gear up, throttle down, which I can talk more about later if you're interested. And look at this. Okay, so I and some colleagues did a survey, and we asked people some questions about their spray application. And one of the questions we asked is, do you adjust your sprayer during the season? 38% of our respondents said no. They go with one volume, one setup, and they go all year. Does that make any sense? I mean, look at this. So when we're talking about canker sprays, pruning wound sprays, where you don't really need the fan at all for a pruning wound spray, and or you could certainly go very low. Early season, your first mildew spray. This is a lot of wasted material. So this is an excellent time to think about slowing down your fan. You can speed up your ground speed. You can try larger droplets. This is almost my last slide. And this is basically what you need to know if you're going to select a pump, right? So if you're going to go in and select a pump for your sprayer, you basically need to know what the flow rate you need is before you go in, because that's what they're going to ask you. So you need to know the flow rate of the nozzles. So you need to think about how much flow you need to get good coverage at the height of the season. If you have agitation requirements, so do you have hydraulic agitation? Some sprayers have these self-cleaning strainers, and then they add an extra gallon per minute to assure proper flow by the bypass valve. And then it's recommended that you multiply these requirements by 1.2 to get an extra 20% capacity for pump wear. Okay. Centrifugal pumps, I can talk more about these later. I'll just share one last story with you. Here's a grower who asked me, in my region, sometimes people buy the Vineyard and they inherit the sprayer that the previous owner bought, for that Vineyard. So this was an inherited sprayer. It's a centrifugal fan. Went out there and he was like, I can't get any flow. Help me calibrate this. And this was an orchard and vineyard operation. It was an organic operation. They had been spraying a lot of sulfur and a lot of horticultural oil. And this strainer right here, we couldn't even get this out. It was so impacted. So the flow had to go through the strainer before hitting the pump. No wonder we couldn't get any flow. So, strainers are incredibly important. And so no matter what sprayer you choose or have to work with, if it's not calibrated and it's not adjusted properly, it's not going to give you good results. And I thank you very much for your attention.